press on. Okay, recording is in progress. You can begin.
Okay, guys. So I'll start over again. So this submission was made by Roland John. So this is just a demo that we'll be using to just give you some tips and tricks, so you guys can improve your further documents. So is my hearing? Is my speaking okay? Can you guys hear me?
Yeah.
Okay.
Yeah.
Okay. Okay, guys. So we'll continue. So say suppose you given this like this, right? You don't know which one is which. So firstly, what you'll do is you'll try and arrange them into headers, different headings. So we were here. So we going to modify our heading now. So it should be automatic, and then bold depending on the situation, and then Times New Roman. Okay, you can also change the font size. So that's for heading 1. The same way we'll be doing heading 2 as well. So initially heading 2 is like this. This is not yet modified. So we go to heading 2, modify our heading 2, and then we'll make it automatic, then bold, and then the font size will automatically decrease. Then again the font, we change it to Times New Roman, and then we press automatically update. Okay, so it updates automatically. Set. So once we have this, we can generate this table. So this was the original one submitted. So suppose now that we want to generate the table. So what we'll do is go to the reference tab, set table of contents, and we'll just use the first one. And there you go. This has been generated for you. Okay. So any questions regarding this? So the second, guys. Okay. So now that we know how to make our table of contents, you can label this as you would like. Table of contents, etc. Okay. So now that we have this done, let's move on to the next stuff. Acknowledgement. So the abstract. So this here are two. This here is the original one submitted by the person, Roland, and this here is the justified one. So it's better you justify your paragraphs so that it's gonna be easier to read and comprehend for the person who's gonna be reading it. And of course, the justified version looks okay, better than this one. So it's better to go ahead and do this. So the shortcuts is select all that you want to be justified, Control J. That's it. Okay. And then if you want to do it manually, you select it, go to the Home tab, and then this is the justify option there. See, Control plus J is written there. So once you do that, it's justified. That becomes easier to use and easier to present as well. So this ensures that your marks will not be cut in formatting and layout. Okay. So the same goes for the introduction. And then a quick shout out to the problem statement. So some tips on how to write the problem statement are what, who, when, and where. So you're basically describing your problem in this statement. So whenever you try and describe something, you start off with what, who, when, and then where. So basically looking at this person started off with the location and then some general information about the problems. So the village is in beside the sea, and then no more islands in a long distance, and then usually experience, and from there he has specified it to experiencing strong winds. So now he's starting to get into the problem. So now then he says that the village people do not have hurricane proof homes, and then he gives some more details, and then it takes a lot of time to rebuild because material is not easily accessible. So this is an example of a problem statement. So this is something how it should be done. Okay. So moving on to the design brief. So one student in the morning session asked me to describe the difference between a design brief and a design criteria. So this is a very simple question, and the answer is even simpler. So a design brief basically is we can say this is simply the aim of your project in simple terms. So the design brief is to design a house roof that is able to withstand the strength of strong winds and cyclones. This is what you try and achieve at the end of your project report or project. And looking at the criteria, the design criteria, what this is the different types of specs that your house should meet. For example, the roof should be firm and last for more than 20 years. And say suppose using screws for coverings instead of nails. So of course, if you use screws and instead of nails in your building materials, it's going to be stronger. So that's more like it. Just a quick word on literature review. So again, justify this. So one error that I've seen in the morning was that you're referencing. Whenever you're referencing any used article or any type of research, make sure do not italicize it.
You need to. So your screen is still on literature review.
Okay.
So we weren't able to see anything on the problem statement and so on. I think it's frozen or something.
Okay, can you guys see what I'm showing you now?
It's still on literature review.
That's strange. Okay. Just hold on a second. How about now? Is it okay now?
Yes.
Is it okay now?
Yes.
Yes, sir, thank you.
So I'll cover the design brief again. So design brief is basically what you aim to achieve by the end of your project. So simply it's a house roof that's able to withstand the strength of strong winds and cyclones. And your design criteria is the different types of specs that your product should meet. So for example, the roof must be firm and last for more than 20 years, and the screws and coverings instead of nails. So that, and then moving on to the literature review. Then again, justify your literature reviews. Make sure. So you start off your literature reviews with and just hold on that point. I think Dr. Kabir mentioned that you guys will be changing your literature reviews to background research. Is that correct?
Yes, sir.
Yes. So I just got to know this in the morning. So his literature review in fact started from here. Okay, can you guys all see this in the early 1970s?
Yes, sir.
Okay, that's good. So he has kind of started the literature review with some background knowledge on housing, on the roof systems. So you start off a literature review from general background research, something that's close to whatever you want to do, and then from there you focus on your main topics. Okay, then you detail it out, and literature review is basically reviewing what others have done and then publishing it here. In fact, using the research and then reviewing it. Okay, so again, so this is the some of the things that he has found out, the common types of designs, roof designs, and then he has discussed on them in the next paragraphs. So since now it's a background research, so it's gonna be easier for you guys as well. Okay, so what point I wanted to emphasize was when you're trying to use any research and then put it in your article or put it in your reports, ensure that you do not italicize your writings. And there's an error here, as you can see. There's a small error.
No,
Can you guys mute it, please?
digital. Hmm.
Thank you. So there's a small mistake here. What actually happened here is that he has used the full stop before your index citation. That should not be the case. You will be marked on this. Full stop should be there. Is that clear?
Nah.
So that's that. And same thing, justify and everything. Okay. So the possible solution and the evaluation criteria.
Nah. Motor लेके जाओ.
Hello, Shabnil, can you please mute your mic? Okay, thank you. So this here is the decision matrix, right? So what he has done, he hasn't. This was just how he submitted. Okay. Of course, the table below describes the possible solution and evaluation criteria, right? But it's best to label your tables, table 1, table 2. So in order to do that, let's go to the references tab and then you insert caption. Okay. So you shift the label from figure to table and then you type in decision matrix for analyzing roof configs. And select OK. And this is how you get it. Now you can also edit the captions the same way we did the headings. So once that's done, you make your table. And there's one other point I'd like to make here. So your total scores. So we all know that we'll be summing up the scores and then the higher is better. But that's not the case in every decision matrix that we make. Some advanced designing courses have used lower to be the better. I mean, lower score is the better option. So it's better you key it out here. So you can say lower score is better. That will help the person reading it to understand your scores and then get a get good comprehension of your scores. So that's the point. And then moving on to some figures. Make sure you label your figures. This can be done same way, referencing, caption, and then shift your label to figure. And then type in your figure name, and there you go. So doing that gives you the access to these small in-text referencing. So what happens when you go and make your table of content? Okay, after you make your table of contents, you can also make your list of tables. So what happens here? You can insert your list of tables. You go to this insert table of figures tab here, and then select table, generate. So this automatically generates all the different list of tables here. Say suppose you have 25 tables. How will you go and make it like this? How long will you spend on it? So it's better to do this. Same way, you can also insert your figures. And there you go. Just have to label it. Table of figures, etc. Okay. Then a few more points left before I transfer it off to Krishnil. The labeling is done. Now comes the editing of photos time. So these photos have been edited by me in the morning. Well, I showed the first lab session, guys. And so this is the actual pic that I got from this person. This is what was written here. The figures were not labeled, even the borders were messed up. There were no borders actually. And the crop was, the size of the pic was not optimized. So what you can do is double click on the pic. There's a crop button right here. Press it and then crop out your pic to have just the important parts. There you go. Now that has been cropped. So you can double click on this and then you can select a picture border, go to black, and there you go. And you can label this as well. So go references, insert caption, click it to, etc. And then once you update the tables in your table of content, it's gonna update automatically. Same way for this. And all the pictures. So these are some of the basic stuff that needs to be done while you are writing any reports. The same goes for discussion. See, justified, it's not justified. Some comma grammatical errors. This can be solved all in the Word itself. So these are some of the stuff we needed to share. And one point in the referencing. So I'm sure you guys must be knowing how to use referencing, but just a quick shout out to the referencing section. When you go to the manage sources section, there's gonna be some references that you haven't edited properly. Like they were not even inserted properly. Yeah. So when you edit it, make sure that your surname, the surname of the author comes first, comma, and then their first name or the second name, and then you have your semicolon. So he's given this correctly. However, there should have been a semicolon, and the same for the second name. So once you take it, edit it, this was this, I believe, 7. So once you update all of your settings and update your bibliography, you get a properly done reference. This is very useful if you have got more than 50 references, and this will also keep you in track. Okay, so these are some of the basic stuff for editing Word files. I'm sure you guys have gained something from this, and I'll transfer the screen now back to Krishnil, and he can further discuss the lab today. Thank you.
So you guys can hear me well? Just type yes or no. A few of you.
Yes, sir.
Right, set. We will begin with the CADLab 5. So CADLab 5 is on three-dimensional drawing 3D, and it covers fillets in 3D, revolving, dimensioning of 3D objects, creating profile images of 3D solids on paper space, and section and slicing of 3D solids, and finally hatching. So first of all, you must all know how to switch from drafting and annotation to 3D modeling. So you move the cursor to the bottom toolbar menu, where we have settings. You left click on that and click on 3D modeling. So once you click on 3D modeling, you will have a set of icons appearing on the top toolbar menu, portraying some 3D dimension, 3D commands such as extrude, box ejector, section plane, the views. Second thing, make sure your units are in millimeters. So you type in units, press enter. So type that in again, units, press enter. Then you select your precision, the insertion scale, change to millimeters, click on OK. So now your drawing will be made in millimeters. The screen is still frozen. No. So I think yes, screen is frozen for you because of internet connectivity. All right, so we'll continue. So as last week I've discussed, remove the cursor to the top toolbar menu, you can access views. This means that after you've made an isometric object, you can see the top view, bottom view, and left, right, front, and back respectively. And we have 4 kinds of views. We have southwest isometric, southeast isometric view, northeast isometric, northwest isometric, right? So this basically depends on the UCS in the direction of the z-axis. So we basically mostly use southwest isometric. So you can left click on the UCS and move it about. So we will switch on the restrict cursor orthogonally in the bottom toolbar menu. We'll place the UCS somewhere this corner, and we will switch on the restrict cursor orthogonally again. Now, if we select a normal line, we will not be able to join the object and extrude, right? We have to select polyline. For example, if I'm making a cube of 10 by 10 by 10, so enter 10, 10, 10, again 10. So there is a square. I have used polyline. Now, if I move the cursor over and I left click on it, the entire object will be highlighted as a square. Right now, if I extrude that, all the sides will extrude together, and the top of the object will also be closed. So I type in extrude, enter, I left click and enter. So our side is 10, we are making a cube. So 10 by 10 by 10, height will be 10, enter. So there you have it, cube. And now we will be going through the first command of this lab, which is fillets. For example, this is a sharp edge and we want to fillet it. So we must select the fillet radius. If this is 10, okay, it says this meeting now has unlimited minutes. So we can continue for a longer time. This lab and whatever Avikash has explained will be recorded and I will upload it on Moodle, right? For your later reference. So for the fillet command, you type in fillet. Remember, AutoCAD is not case sensitive, okay? So you can also type in capital letters and lowercase letters. So you type in fillet, you press enter. Select the first object to fillet. There's only one object. You left click to select. And I have to move this in. Yeah. So it says to enter the fillet radius. So for this edge, I have selected, right? So the fillet radius will be 5 for me, 5, enter. And then select the edge. Radius, fillet radius 5. Select the edge and then enter. You press enter and then you'll have a fillet created. So any questions with this command, you can ask now on chat. Or you can unmute and ask. No questions, fine, we'll move on. Now we will move on to the revolve command. Let's say for the revolve command, if we are making let's say you are making a cone, right? So we will just select a line. We will make a line, let's say 40. And then other two lines, we will have this, let's say 20. And we will join this back to form a triangle, right? So for the revolve command, you type in revolve, you press enter, you select the object to revolve. So these two objects we can select, we are revolving it. So after selecting the object, you press enter. And then this will be our axis. Our object will be revolved around, right? So I have to specify the first and second point of the axis. They have been specified. And then you can specify the angle of revolution, right? That will be around 90, 180, 270, etc. So let's type in 360. So we have that, our cone, right? So let's see it in X-ray. There. You can switch off the grid if you want. And switch it on again. So I hope you are clear up till here. Remember, the X, Y, and Z axis can be used for revolving also, but the origin of the axis may need to be move to be along the path of the object axis, right? This is where the UCS comes in. Now for dimensioning 3D objects,
So we will be using HG.
now let's say we want to dimension this cube, right? So for dimensioning this particular cube, you have to move the UCS here, right? For example, you want to dimension this edge here, right? Are you guys still able to see the screen? And the case are moving along that particular edge.
Yes, yes.
Okay. So you will move the UCS my battery is low. I just connect my laptop to the charger. Okay, so I will move the UCS and place it along that edge. So if X and Y is facing that way and Z is facing upwards, so my you just see how my dimension will be carried out. So you type in dimension, enter, and then you specify the corners, right? And the dimensioning will be carried out along the XY plane. And then you left click to place it there. Now you can zoom and see the precision, the size of the arrows. You can change that in dimension style settings. We have covered that in Elia Labs. Now let's say I want to dimension this. No, let's say this edge here. So I will place that there. Now how will the dimension be carried out? It will still be in the XY plane, right? But that is the YZ plane. So I have to make that plane the YX plane. So I can alter that and say that is Y and X. X, I can face it that way. So it will carry it out in the XY plane, YX plane. So dimension, press enter, select the edges, and there you have your dimension. So I hope that is clear. That was the dimensioning of a 3D object. Now we will move on to profiling or solid profiling. So here we have a cube, right? We can see the front portions, but let's say after making a particular isometric view, we do not want to see the hidden lines. For that, we have the solid profiling command, or in short, solprof. So we go to layout. You double click into the drawing space. Let's say let's center that and increase the size a bit by zooming in. And then you type in the solprof or solid profiling command, press enter, and you select the object, and then you press enter. And it says display hidden lines in separate layer. Click on yes. You can also click on no, right? It will not display the hidden lines on the separate layer. So here project profile lines onto plane, you can select yes. Yes. You can also select no to see how the drawing varies. So we have selected all of that. We move back to the model space. Now, if we move our cursor over the isometric model or the cube, this the lines that are shown will be highlighted separately. The hidden lines will be highlighted separately. Now you can left click on them, go to isolate, and click on hide objects, and then select the object, press enter. You select that again, isolate, and hide object, and the hidden lines will be gone. And same as that for layout, because whatever we have on the model space will eventually show up on the layout space. Now, having that done, we have covered the solid profiling part of the lab. Finally, we will move on to sections and slicing, and finally hatch. Now for the sectioning, we will make a different kind of object. So let's delete this. Select polyline. Let's say we make a cube of 20 by 20. So we have a cube of 20 by 20. Let's extrude that to a height of 10. And let's have a countersunk hole in this cube. So we are using these lines as a reference to find the center. Or if you want to find the center of that, you must go to the bottom toolbar option, select snap cursor, and you can find out the geometric center of the particular shape, the center, midpoint. You can just check that on and that will appear in your drawing. So now you select circle. Let's say we make a circle here of 6 mm radius. Then you delete the reference line. So we will extrude that circle inwards. Left click on that, press enter, and it will extrude inwards at a negative height of 5 mm. So you have that. Now you can use the subtract command to make a through hole. So you are subtracting the circle from the cuboid. So you left click on the cuboid first, you press enter, and the circle you are removing. So you press enter on that and select it. Sorry, some mistake there. So we type in subtract again, press enter. You select on the cuboid, you press enter, you select the cylinder we made and press enter. Something strange. Okay, right, there's something else I missed. So if we type in 3D orbit, this is very important, right? We type in 3D orbit, we press enter, and you move that. You see the cylinder has been made on the XY plane, right, of the UCS. That's why the subtract command is not being carried out. So delete. So you press escape again, you delete the cylinder. We go to southwest isometric again. Now, if we want to make a circle along this top plane, so we must move the UCS onto that particular plane, right? So we switch off the restrictors orthogonally at the moment. So we move this there. Try to move again, left click and move and place it there, right? So we have it placed on the top plane, right? It will be highlighted. So we make a reference again. And then we select circle and make a circle of 6 mm radius. We delete these lines. All right, and then we extrude in the negative direction. We select the circle by left clicking. Press enter. And specify the extrusion height. We are going inwards, right? So 5 mm. And then you type in subtract, press enter. So you are subtracting the cylinder from the cuboid. So you select the cuboid first, press enter, and then you select the cylinder and press enter. Now you see if you move the cursor over the object, this is one object at the moment with a through hole in between. Now to make the countersunk, you can also move your XY plane and place it there, right? And we can also use the 3D orbit and spin it around. And we are making a circle here to connect to that to make a countersunk, right? So orbit again. So we are there. You can select line as a reference. So then we will make a circle of, let's say, 3 mm radius. Press enter. Delete the reference lines. And then you extrude that upwards to join here. The height was 5 mm, so 5 mm we've extruded downwards, 5 mm we can extrude upwards as well. So specify 5, enter. So those two will be joined, right? So now you can use the subtract command again, press enter, select this object, enter, and then the second object, enter. Now this is one particular object. Let's view in wireframe, X-ray. Let's go to 3D orbit. You can see there's a through hole. So now let's get that back to southwest isometric, right? So the UCS is in the bottom plane now. And the extrusion axis is in the Z direction upwards. Now let's press escape to exit all the commands. And let's go through the section command. Now, if I type in section, and I press enter, it says to select the object. So this is my particular object, right? I'll go back to 2D wireframe. So we type in section again, press enter. So this is my particular object. I'll left click on it and I press enter. And it's just to specify the first point on the selection plane by object Z axis view. I'd prefer XY axis wise, right? So, but the section will be carried out either in the along the XY axis the YZ axis or ZX axis. If you select XY axis, so the section will be carried out somewhat like this, right? And in the ZX axis, the section will be carried out along the ZX axis. So it will be cut from here, right? And there. And similarly, ZY axis will be cut from here and there, right? So let's say let's try for the let's say we try for ZY axis, right? YZ. So we select YZ by left clicking on it. And then you specify a point on the axis, right? So the object will be cut or sectioned along the ZY axis. So from the end point, I moved inwards with the line. Let's say I want to cut it this way, right? So I move till I reach the midpoint. And let's say I will section from the midpoint. So I just left click there. So the section has been created inside, right? And now let's try for the XY. So I type in section, press enter, select object, left click, press enter again. So specify first point on section plane. So I will click on XY. And I will select the midpoint is there. So I will left click and create the section. Now we can also slice by creating the section, right? So now if I type in the slice command and I press enter, and then it says for the selecting the objects to slice. So I left click on the object, I press enter. So then I will select XY again, and I'll specify the point on the axis, right? So from there to there, I'll select the midpoint and I press enter. And it says to keep both sides or not. So I'll just select keeping both sides. You can select yes or no. You can just type in there Y or N, right? So let's say I will type in Y here and I press enter. Or I just select by left clicking on keep both sides, and both sides will be kept, but the section will be created in between. So now if I move the cursor over the object, the top portion after slicing will be highlighted separately and the bottom portion will be highlighted separately. Now let's say if I want to show the section portion as the bottom one, so I can delete the top one by left clicking and deleting it. And now I want to show the section portion, right? So I can use H over there because it is usually shaded. So I can type in H and I press enter. And I for hatching and you must move the UCS and place it there, right? So then you type in, I just close the door of the room. Sorry. Sorry for that. So you type in H again, press enter, and then you pick the internal point. Why ain't I able to select the internal point? Let's try 3D orbit. I'll rotate this. So type in H again, press enter, and pick the internal point. We are not able to pick the internal point. I think there is a discontinuity between the lines. Let's try slicing again. So this time, let's say I slice selecting the object, pressing enter. And let's say I'll slice in the YZ plane. So select YZ and then specify the particular midpoint. I keep both sides. I delete that. Then I try hatch again. I pick the internal point, let's say. Hold on, see what the problem is. I can slice. Left click. YZ. So if you do not want to keep both sides, I think you have to just type in N here. No, that is not an option. I'll just keep both sides and I'll try hatch itself from here. I can delete this by left clicking. I'm not able to pick that as internal point, but I'm able to pick all these that I have made earlier, right? So I will just move ahead with this example. So I think you can click on select objects and pick internal point. So it says that a closed boundary could not be determined. There's some problem with the particular object. There must be some problem during extrusion or subtracting. But in simple, let's say I pick this as my, I type in H and that is a closed boundary, right? So I left click on that and you can select whatever kind of H you want. Let's say you want that. If you are not able to see it, you can also double left click on that and increase the scale, I guess, to, let's say, increase the scale to 5. Press enter. And there you have. So you can also type in 2, enter. You can also have your hatched color. So I think this will be useful when you will do the design, final design for your project, right? I think for some projects you'll have to show the section view. So that brings us to the end of today's lab. If you have any questions, you can ask. Use this time to ask. I'd prefer if you unmute your mic and ask. So any question before we finish the session? Can we make an object in one? Can we make an object in one plane and change its plane? No, you must make it in only one particular plane. You can only change the plane and then make the object. You cannot make the object and then change the plane. If you make the object, the plane will be changed with it when you rotate. Any other question? Attendance, Varun, have you taken the attendance? Varun, hello. Yeah, Arib, Varun already took the attendance from the triple B session. Anything else before we leave? Okay, so that will be end of today's class. Thank you for your time, guys. Stay safe and take care. All the best with your project progress report and your labs.